National Geographic Reading Expeditions, Newton's Laws, by Glenn Phelan. Moving by the rules. These kids will quickly reach the bottom of this giant slide. Once they're on flat ground, they'll continue to move forward before slowing down and stopping. Why don't they stop immediately at the bottom of the slide? The kids continue moving because they have inertia. Inertia is the tendency of an object to resist any change in motion. Inertia and force. You see inertia's effects all the time. Once an object is moving, it tends to keep moving. Something has to make it speed up, or slow down, or change direction. Also, when an object is at rest, or not moving, it tends to stay at rest. Something has to get it moving. That something is a force. A force is a push or a pull. A force can be gentle, such as the pulling this book towards you, or a force can be tremendous, such as hot gases pushing out tons of rock from an erupting volcano. In the caption, a push from someone's hand moved the red marble. What force is about to move the blue marble? How do forces affect motion? Think of a large ship. In order for the ship to start moving, force from the huge propellers has to overcome the ship's inertia when it's standing still. When the propellers turn, the blades push against the water and they move the ship forward. Friction. Once the ship gets going, inertia makes it tend to keep going, but eventually the ship has to slow down and stop. What force makes it do that? Mostly friction. Friction is a force that resists motion when two objects, such as a ship's hull and the water, rub against each other. You can think of friction as the force of two objects pushing against each other. Friction is always acting on the ship and slowing it down. When the propellers are turned off, the force they provide no longer exists. Now, friction can slow the ship to a stop. As the ship approaches the dock, it must be steered into position. It doesn't change direction by itself. It has to be forced to change. By turning the rudder and propellers in different ways, the pushes are exerted in different areas of the water. These forces turn the ship to move forward in the desired direction. On some ships, jets along the side push the ship to the dock. First law of motion. Isaac Newton stated these first ideas about inertia and forces as his first law of motion. It's also called the law of inertia. You can see in that little caption right there, it says the first law of motion. An object will remain at rest or continue moving at the same speed and the same direction unless a force acts on it. Force and mass. Problem. You and a friend want to move a dresser from your parents' room to your room. The dresser has 4 drawers and it's too heavy to move. Solution. Remove the drawers and carry them one at a time, then carry the empty dresser. Problem solved. Let's look at the science behind that problem. The dresser was too heavy to move, even by 2 people, because of its large mass. Mass is the amount of matter that something has. You and your friend could not provide enough force to move that much mass. You could have moved it by adding more force, but no one else was around to provide that extra force, so instead you decreased its mass. Each of you could provide plenty of force to move the mass of a drawer. Together you had enough to move the empty dresser. Can you tell that force and mass are related? Good. Now you're thinking like a scientist. The second law of motion. Newton discovered that force, mass, and acceleration are related. Acceleration is the change in an object's speed or direction over time. Newton summarized the relationship between these ideas in his second law of motion. That simple equation is pretty amazing. It can tell how much force is needed to move an object or a certain mass, or it can tell how much a certain force will make an object move. It can also tell how much mass an object must have in order to move the way you want it. Second law of motion. An object's acceleration depends on the mass of the object and the size of the force acting on it. Newton wrote it this way: force equals mass times acceleration. Looking at the bottom where it says thinking like a scientist, predicting, Newton's laws can be used to predict how objects move. For example, the 1980s javelin throwers were throwing so far they began to endanger crowds in the stadiums. The International Amateur Athletic Federation made a javelin heavier. They used Newton's second law to predict that the added mass would make the distances shorter. They were right. Predict what would happen if the mass of the javelin was decreased. Pushing back. You're trying to teach a friend how to ice skate for the first time. You give him a little push from behind to get him going. He goes forward, but to your surprise, you're sent backward. You lose your balance, and you take a little tumble. Falling was not what you had planned. After all, you are the expert skater. What happened? Well, your friend pushed back without even trying. Sound crazy? No. Sounds like Newton's third law of motion. The third law caption: when one object exerts a force on a second object, the second object exerts a force of equal strength on the first object but in the opposite direction. In other words, for every action, there's an equal and opposite reaction. Continuing on, Newton figured out that forces always work in pairs. One force is an action force, the other the reaction force. The push you gave your friend on the ice was an action force. The push you received back was the reaction force. On the ship, the propellers push against the water. That's the action force. The water pushes back, the reaction force, and the ship moves forward. Tug of war. The third law of motion is in action all around you. For example, when you walk, your feet push against the ground pushes back and moves you forward. Sometimes it seems as if the action-reaction forces are not equal. Suppose you're sitting at a heavy desk doing homework. You grab a small book and you pull it towards you. The book is pulling on you with an equal force, as stated by the third law. If that's true, why aren't you pulled towards the book? Well, that's because your mass is so much greater than the book's mass. Remember Newton's second law? The same force accelerates a small mass more than a large mass. You're pulled towards the book just a little, but not enough to notice. It's like a tug of war between you and the book, and you win easily. But what happens when you pull on the heavy desk? The desk wins this tug of war. It pulls on you as you pull on it. Its mass is much greater than yours, however, so you move towards the desk. The laws of motion are among the most important ideas in science. They explain the momentum of everything, from tiny gas particles in the air to huge planets in space. Figuring out these laws took a real genius.